friends. If you're here, you're coding with Paris. And previously, we started talking about the 3 essential pieces, in my opinion, that you need to understand most of object-oriented programming. And those 3 pieces are classes, inheritance, and polymorphism. In the last video, we dove into classes and how they are the blueprint that allows you to quickly create objects and reuse them throughout your code. Now let's add on to that skill in our mission and learn about inheritance. Okay, my friends, in previous conversations, we talked all about classes and what they represent in code and why they're important. Remember, classes are that blueprint that allows you to describe what an object looks like and allows you to be able to quickly generate objects based on those blueprints. Again, that gives you lots of speed and reusability and some level of documentation or some level of description of what your code is doing. Right? That's awesome. But there's another tool that you can stack on top of that called inheritance. If you haven't seen the previous video on classes, go ahead and check that out before you continue here. If you have, we're going to go ahead and dive into what inheritance is. The word inheritance is probably very familiar to you, but inheritance in code just means there's a set of state and behavior that certain pieces of code can get from related pieces of code, from parent classes. In other words, we have classes and classes can inherit from parent classes. The beauty in that sort of behavior, again, is speed. This allows us to take a class and quickly build onto that maybe related functionality, but more specific or special. Also, at the same time, it allows you to document what your code is doing. Now that your code is taking form with classes, you can see what behavior is going on. You can see what's related to what. And so you can see how something like this might build productivity. But what does inheritance look like in JavaScript and other languages? Let's talk about JavaScript first. So let's go over to our Coding with Paris folder. Of course, we have our folder highlighted. What we're going to do is we're actually going to create a new folder called Lesson 8. And like always, we're going to create a new file under that. Inheritance. I'm going to give my spiel in this video and every video. It's good to watch videos and learn, but of course, if you want coding to stick, the best thing to do is watch this video the first time to absorb the material and then go ahead and try to do this stuff on your own. So as soon as you can, get home and start typing this stuff up, failing fast, because that is what's going to make this material stick. And if you haven't already, go ahead and open up your terminal, and you can do this by going to your terminal window and clicking New Terminal. You can see I already have it up. So let's dive in. Let's talk about inheritance in JavaScript really quick. First thing we're going to do is we're going to create a simple vehicle class. We're going to say class vehicle, and we're going to come up with some instance variables for that class. Okay, so let's use make. We will also do model. We'll do wheel count. And we'll do color. Then we'll come down and do a constructor. And this is going to look very similar to the previous example, if you haven't noticed already. So our constructor is going to take make, model, wheel count, and color as input properties, right? So these are things that we pass into our blueprint as it's manufacturing our vehicle object. And we'll have this constructor, which is the first piece of code that's ran, go ahead and assign those input properties to the proper instance variables, okay? So in here, we'll say this.make, this.model, this.wheel count, this.color. And then finally what we'll do is we'll just add an example of a method as well. So let's go down, create a method called goBeep. Okay. So then we're going to log that out really quick just to see what it looks like. Let's go outside of that class here and write console.log new vehicle and see what it looks like. Down in our terminal, I'm going to make this a little bit bigger for you to view. In our terminal, let's go ahead and figure out which folder we're in. You can do that by print working directory command in the terminal. This will show you where you are. We're in the general coding with pairs folder. To go into the folder that you want, you go CD and you go lesson 8. And from here, you see inheritance.js. We'll use our node to go ahead and run this function. And this reminds me, if you need to know how to set up node, I do have a video on how to set up your coding environment to follow these examples. I'll link it down below, but go ahead and check out that video and previous ones to this to catch up to what's going on, because this content builds on each other and it's hard to take it out of context. Anyway, let's call inheritance.js. So you'll see here that this is this vehicle is created. Nothing's inside of it yet for the properties, but this is good for you to know because now you have an object you can reuse all over the place, right? But we already covered that. So let's dive into a little bit more of what inheritance is talking about. So in your code, what you might want to do is you might want to indicate when some functionality is closely related to each other, as well as you might want to reuse some things you've already established. So we have a vehicle class, and let's say we want to reuse all of the stuff that we've already created with this vehicle class to create a more specific class called a car. In order to do that, what we can do is class, and you can use inheritance by using the extends keyword. This lets the programming language know that you want to reuse this vehicle class. And what we're going to do is try logging this really quick just to show you what it looks like, okay? So let's go ahead and do console.log, and we're going to create a new car. And this is what you get. We'll go down to our terminal, press up once, and you'll see that node has inheritance.js. This is basically the previously ran command. Hit enter, and you'll see that our new class here is established with these properties already in there. And they're undefined, but that's okay. We'll talk about how to fill those things in. The whole point is, right away, we're able to take some things from this class. So we'll add that note there for you later. Now with inheritance, we saw that we have all of these properties, but there's other cool things you can inherit for free. For example, if we come down and we say console.log and we say new car, but we tell that car to go beep, as you can see, my editor already knows that this method exists. See what we get for free. I'm gonna go ahead and comment that out, come back down here. We're gonna comment that out too. And we're gonna come to our terminal and hit enter, and you'll see this object that we just created here already has the ability to go beep. Folks, can you see how this is going to make you very productive? Let's keep going here. Now, I said before that we're going to swing back and address the very obvious issue that our properties are empty. What's the use of inheritance if that's empty, right? So let's talk about how we would use inheritance to fill in those parent properties, those properties that this car class inherited from its parent, the vehicle. In JavaScript and in a lot of languages, we're able to do this using the super keyword. We'll just type it up here and then we'll talk about what that means, okay? Let's say we create a new class, car2, and this car2 also extends vehicle. All right, but let's make this vehicle a little better, right? We'll actually add a property called hasDropTop. We'll set it to nothing at this point. And then we'll come down and we'll say constructor, and we'll have that constructor pretty much do everything that was happening up here. Okay, so we'll go ahead and do that. But because we want to fill its previously established properties, right, things that aren't mentioned here, automatically what we do is we use the super keyword, and this super keyword allows the language to understand that you actually want to use the parent's constructor, right? So actually this is, you can replace this with the parent's constructor, and what we do is we can just add those things there. And let's go ahead and log that out below. And for confusion, we'll go ahead and comment that out. So we're gonna log that out, right? Console.log new car2 class. And in our car2 class, what we're gonna do is we're gonna pass in some properties here because we gotta. And let's go ahead and we'll add Honda for the make, Civic for the model, 4, and red. Okay, and let's see what that looks like. So We'll go down here, we'll clear that terminal, and we'll go ahead and run this class here. And you'll see that now this car class 2, which is showing you that it's a car class 2, right? This is the type car class 2, but car class 2 actually has its properties filled in. And you'll see it has drop top is null. Why that's happening is because we did have an additional property here that we created specifically for this class. Again, you might want to get very specific here. I mean, this car is an extension of a vehicle, but we have other details we want to add. We can do that by making this constructor take a value that has drop top, and maybe this value is a true or false value. And what we can do is just say this dot has drop top equal has drop top that's passed in. Okay. So now you're starting to see that we can fill the parent's constructor by using the super keyword, but we can also fill our own properties and do whatever we want to do in our own constructor, because the constructor by nature is the place where we want to do any setup for the instance that pops out the other end of the factory. Now that we have that set up here, when you run this again, oh, obviously we have to pass it in. Let's add a false value and run it again here, and you'll see that now this Honda Civic doesn't have a drop top edition. However, let's say if we do have a drop top edition, we might want to add not only specific properties to this class, we might actually want to add its own behavior as well. And so we can do this by adding its own methods, right? So let's say it does have a drop top, and what we're going to do is just say drop the top. It will not take any input, but what we'll do is we'll just put an if statement. So if this dot has drop top equals, let's do that, triple equals true, then console.log drop the top. Else console.log your model doesn't support the drop top. There we go. Right? And so if we came down here now, and if we take this line, copy this line down here, and also told it to drop the top, which is a method. Remember, open and close parens in order to call the method, right? To make that class perform that act. Log that out in the console. You'll see that the drop the top method was called. This is dandy, right? Folks, what I'm showing you here is that you can not only create a class that can reuse what you've already established, but you can make this class more unique. You can make this class better by adding its own properties and its own methods, or its own state and its own behavior. And this extension can help you speed things up. Now you can still get access to a vehicle's methods and properties at any time. Again, if we were to go console.log and we were to say log car2, let's just create a new car2 on the fly again. And we just said, just give me the model. I just want to see what the model looks like. This should print out Civic for you. And that's great. But there's something else you should know about inheritance, okay? And that is, in some of these cases, you might want to go ahead and inherit all of what comes from the parent, like our make, model, wheel, and color. But you actually might want to override something that comes from the parent, right? Because in this example, things are different. So what we'll do to kind of show that example is we'll go ahead and create a new class. And that class would be a motorcycle, which it makes sense is that that's something that might want to extend a vehicle in your code. And like we did in our previous example of the car, what we'll do is we'll create a constructor, and we'll have that constructor take the make, model, wheel count, and we're going to change some things. That we'll take a primary color and secondary color. And of course, because we are inheriting from our parents, we must fulfill our parents' constructor. So we'll use the super keyword, and we'll use the super keyword to take the make, model, wheel count for sure. But we don't have color as the way it's defined here. We'll go ahead and set that as undefined, and we'll talk about that in a second, okay? Let's print that out quick. So we'll go down and say console.log new motorcycle class. Let's see what that puppy looks like. We'll go down to the bottom, press up. Uh-oh. All right, real quick. We can't have a missing comma here. and that's what I had going on. So we'll clear this noise, press up a couple times. Oh, we still have an issue. What's that? And there we go. All right, and in here what we're going to do is we're going to pass in, let's just pass in some of our same stuff as we did before. We'll do these three. So we'll go console.log, new motorcycle, and we'll pass in, let's change it up, huh? Let's do Kawasaki and Ninja. Okay. And then from there, we'll pass in the 4 and take out the car stuff here because we just want the new motorcycle. We'll go up here and run it. You'll see that we have all the properties set except color, which we purposely left undefined here. The reason why we did that is because, again, we might want to override or do some very specific things for our class. So let's do that here for color, okay? So instead of using our previously built-in color that's established here, what we might want to do is override that with color equals primary color, and we'll do a two-tone color. So we'll do primary color and secondary color, and what we'll do is we'll find a way to take this primary and secondary color that we talked about here and apply that. So what we're actually going to do here is we're going to create a method, and this method is going to be a private method, and we're going to say set primary and secondary color, and we'll take that primary and secondary color and do some magic with it. Okay, we don't need this here, we need this in another place, and we'll talk about that in a second. So then we create this method here, and we'll have this method, set this dot color dot primary, which we established up above, primary color, and we'll do this dot color dot secondary color equals secondary color, as we have established here. And finally, we go up to our constructor method. Remember, our constructor runs some code when the class or the object is first established, and at the time of construction of this object, what we want is this dot set primary secondary color, primary color, and secondary color as is presented here in the constructor. All right, so because we were able to do that, if we go down here, and then what we need to do is add a primary secondary color to our constructor. So we'll do a blue, we'll do a couple of blue, and we'll do gray, and now we can log and see that now we have a color property, right? And that color property is different from the one that was originally set up in the vehicle parent class. This motorcycle allows for a different implementation or an override of that with two colors, right? With a primary and secondary color. We can also override methods as well. So let's say instead of using the normal go beep class, I'm going to scroll up really quickly. The normal go beep class here for the motorcycle, what we can do is we can make a tinier, cuter sounding beep for the motorcycle, because we know motorcycles aren't as big as cars, right? So let's go into our class one more time here, and what we'll do is we'll create a go beep method, right? It's called go beep, it's the same thing, but in here what we do is we go console.log, and we'll say meep meep, right? Which sounds tinier and cuter. Now what we can do down here is install that method here, console.log, and we can say new class. We'll just copy everything here, but then we'll tell it to go beep like we would with the vehicle class. If we come down here though and press up and press enter, you'll see that now the motorcycle, instead of going beep, we've overridden it with the new method here. If I were to take that out for giggles and come back down here and tell it to run it, it's going to do the big beep, but we put it back and we got overriding. So As simple as this example seems, this is important because it allows us to quickly add things for these specific implementations that make them work. So with these examples here, we wrote two classes, the motorcycle and the car class, that extends the vehicle class, and that allows us to use some of the functionality from vehicle or extend it to do what we want it to do as well. Let's take a look at what an example might look like in Java quick. Okay, so Java is a language that is very particular on the way that you use inheritance, but it still has a concept of inheritance that you would find familiar, okay? So let's take our class vehicle. It looks very similar to our previously created class here, where we have the make, model, wheel count, and color here. And you'll see that the constructor here, remember constructors in Java look a little bit different. You use the class name in the class for it to know that it's the constructor, and then it allows you to set things. So very familiar here. Java is very explicit about the types. This Java class also has the public method goBeep, which we care about, and this is the way Java prints that out. So let's say we want to extend that class, okay? Well, what we wanted to do is similar to our car2 example. We have a private property called hasDropTop. And in the constructor, what we could do is we fill those values and we add a boolean hasDropTop and use the super keyword. One thing I want to note to you about Java is that it requires you use a super keyword to be very explicit about the fact that you want to extend from a parent class, that parent vehicle class. Java doesn't play around. It doesn't let you, it's not wishy-washy, so it will not let you do what JavaScript does and just create the class. You have, if you're saying you're extending the vehicle, then you have to fulfill the parent's constructor. So that's one difference. But you'll see it looks very similar. And the same with this hasDropTop value. We filled it here, and that'll follow the same function. And then finally, if we go down to the very bottom here, you'll see that we have this class called hasDropTop, and it uses the if statement to print out hasDropTop, or your model doesn't have that feature. Very neat. We'll move on to describe the second example here, and as you can see, there are lots of similarities here, and you'll see patterns similar to this in other popular languages. Dropping into here, you'll see we have the same thing where we want to take that vehicle class and overwrite. Now, Java doesn't let you overwrite properties. That's one key thing about the Java language that differs from the JavaScript language. But you can still do things like override methods here. So you'll see we have an override, goBeep, and you have to denote that explicitly with the override annotation. Maybe we'll talk about those one day, but there's a way for Java to know that, hey, just so you know, what's going to follow this is going to be something that's going to override something in the parent class. So following that, we have the system.out, meep, and there we go. We have our motorcycle class. Couple of things to note about classes that I just want to make sure you guys understand here, okay? So a lesson learned in classes is that you can fall into this trap of trying to take too much time designing and playing with classes when you're developing your own code, your own products. And it can become kind of a fun game where you're fitting pieces together and you can get lost in the weeds with it. I would say keep your classes as simple as possible, right? Give each class one thing to do and only create a class when you have enough functionality that it makes sense to split it out, okay? Don't get caught up in the weeds of just making classes for fun. Remember, classes are all about productivity, and if you're making 1,000 classes, you might confuse yourself or others who might try to use this code later. The same goes for inheritance as well. So we learned about how we can take a concept called classes and make it even better and more productive by using what we call inheritance. We learned about the structure of JavaScript classes, JavaScript inheritance, and how we can use that in our class blueprints. And then we talked a little bit about the similarities with inheritance and another popular language called Java. Next, we're going to talk about polymorphism. Let's go.